Hello, everyone. Welcome to today's webinar on LEDs and dimming with Leviton and Sylvania Lighting by Ledvance. I'm your host, Timothy Johnson, and I'm the digital editor for Electrical Contractor magazine. The audio for today's presentation should be coming through your computer speakers or headphones. If you prefer to call in, there's a toll-free number in the event info panel. If you have other difficulties, please reach out to me using the chat window. Also, please note that today's presentation is being recorded. So if you miss anything or if something comes up and you have to leave, you can come back at your convenience. Finally, there will be a Q&A at the end of the presentation. During the event, you can submit questions through the Q&A chat box at any time. Our presenters are Bill Grande, Alfred Laspina, and Dr. Arun Dutta. Bill Grande is Director of Product Management at Leviton. Bill has been with the company for 32 years in a variety of engineering and marketing roles and is currently responsible for managing Leviton's residential safety products and lighting controls. Alfred Laspina is the product group manager for LED lamps at Ledvance, maker of Sylvania General Lighting in the U.S. and Canada. He has been with the company for over a decade in increasing marketing roles and currently manages the LED lamp portfolio within the commercial lighting channel. Dr. Arun Dutta is Director of R&D for Ledvance. He obtained his bachelor's from IIT and a doctorate from MIT. Arun has 26 U.S. patents and several international patents. He has been involved in advanced lighting product development for more than 25 years. I want to thank you all for attending. Now I'm going to hand it over to Bill Grande to get started. Bill?
Hey, thanks, Tim. Once again, my name is Bill Grande. I work for Leviton. Thank you all for attending today. Thanks to EC and to my colleagues over at Ledvance as well. We have a presentation today, but we have certain goals and objectives, and hopefully they match yours, and that's give us all a better understanding of some of the challenges that might be out there in conjunction with controls and LED lighting. We'd love to hear any challenges that you're hearing in particular, and we'd like to provide you an insight into where we've gone as an industry and where we see ourselves heading. So we have an agenda put together. We'll do a little brief background, hopefully get everyone on the same level with that, and then talk about some specific challenges or technical issues with dimming LEDs as compared to other loads that we've been using in the past, and then hopefully give you some good pointers on how we could really optimize the performance of these products. And this is really a dynamic environment that we're in these past few years if you look at the changes that have been going on, both for manufacturers as well as the installers and the consumers. So I think it's a good topic. And it's probably not the last time we'll want to talk about it because we continue to see advances at a very, very fast rate throughout the industry. So I'll go ahead and get started, and we'll just, again, talk about a little background and what we were so used to for all these years, as long as we all can remember, certainly myself, and that's that wonderful incandescent lamp. And it's really remarkable of what you think is that invention, how long it lasted in near its original form factor. In the early years, it was basically just on-off. You connected power, you disconnected power, and it was at whatever power you connected to, that was the output of those lamps. But a little after the mid-century, when we started getting into solid-state components, electronic components, and things like that, we had neat ways of making very efficient controls that could dim these lamps. And they were very, very easy to dim. And that's what you see at that fourth bullet, is that phase cut dimmer was really optimal for dimming incandescent lamps. And we have a tremendous installed base of those dimmers throughout the country. At the same time, we're switching our light sources. So the question is, what do we do, number one, on those existing installations, and what do we do for our new installations? And that's some of the discussion that we'll have today. And this is really where the market has gone, and it's moved very, as I said, it's a dynamic situation, and it's moving very rapidly. So it was just a few years ago that you look at that middle picture, right, the old CFL lamp, and say, wow, that's what we were buying tons of, and that's what we were using. But I think everyone in the industry recognized where it was going and that it was moving towards LEDs ultimately. Concerns with CFLs as far as environmental issues, the performance. They did offer, I mean, let's not get, the whole thing is about energy savings, right? So CFLs did offer tremendous energy savings in that respect, but they did have those other drawbacks. And those drawbacks are being addressed by LED technology. So even improved efficiency, more flexibility, color, performance, form factors, all of those things, and you look at the wide array of lamps available today as well as controls, and it's pretty exciting, and just think about where we're heading with these things. As I mentioned, you know, it's ultimately started with energy savings and regulations, and that's why we're seeing the phase out of the incandescent lamps. But there's other factors, of course, you know, just the ambiance aspect of it. That's what people were using them in the past, in addition to the energy savings and just other positive factors on there. The chart at the bottom of this slide just looks at what we hope to achieve or expect to achieve with respect to conservation, energy conservation in the coming years. And if you look at this residentially, probably the greatest benefit is going to come from switching to these new light sources. So it's a pretty exciting time for that. I'm going to turn it over to Dr. Arun now, and he's going to give you a little more information on that.
Hi, it's actually Alfred that will cover this part, but good, welcome everyone. So I just want to talk a little bit here about the marketplace. As we just mentioned that, yes, LEDs are dominating, and that price point has come down significantly. So the original LED lamps didn't have the same shape as an incandescent. They're a lot larger, but even just a few years ago, they were about $25 for a single 60-watt replacement, and now they're less than $4, even less than $3 for a bulb, which is very competitive, increasing the amount of use. As we're doing that, it's going to be important we see what kind of dimming we do. But looking at that in the chart on the left, you'll see that the traditional lighting is declining. It's still there in the marketplace, but it's growing. So this price point is coming in, saving us a lot of money and energy costs as a nation, but also bringing on a lot of questions on how to deal with it in dimming. We're going to explore that. Go to the next slide. So look at the average house. We estimate there are about 45 sockets in a home. And you look at this layout from where they are in our bedroom, and our living room, bathrooms, and even if we look at it in a corporate aspect, the incandescent had a high penetration some years ago. But legislation, which we'll talk about in a moment, is going to bring that today to about half the penetration to even less than almost 10%. And the LED, you'll see, is growing more and more. And that's one, because of price, two, the adoption and how their appearance, it looks the same form factor, and that performance. We're saving energy, the color is perfect, the light output and the lumens, and we're replacing the equivalent wattage. So whether we use it in our attic as a utility lamp, or in our kitchen where we need light, or in our bedroom and dining area for ambiance, LEDs are coming into that space. Going into the next one, look at these technologies. Why is it different? So you see the images all along on the 4 types of bulbs. And top of the food chain, which is actually most optimal, is an LED. The light emitting diode, it's very efficient. And you contrast that to an incandescent where it was 90% of the energy was heat. That's why if you touch an incandescent bulb, it'll be hot to your hand and can almost cause a burn, whereas an LED is a lot cooler because that energy is used in the light. There's a variety of color that comes in an LED that's happened in the marketplace. The industry uses phrases soft white, warm white, bright white, and these are choices that we have. The compact fluorescent lamp was fantastic from energy saving. However, it didn't dim well, took a long time to light up, and folks just aren't happy with it. And this is why LED is replacing. Halogen is a great technology, but let's understand that its life is not as long, sometimes up to 2 years. And if you have to change a bulb, that becomes problematic. So especially in a facility where we want to put in a bulb and leave it in there for a length of time, ideally would be LED. So what brought on LED even further, if we go to the next slide, is regulatory and legislation. So back in 2007, there was an Energy Independent Security Act brought together by the government, which decreed that incandescent halogen lamps had to be a certain percentage, 30% more efficient, and even further by 2020, 40 lumens per watt. What happened is the 100, 75, 60, and 40 watt incandescent bulbs were phased out over time because they could not make that lumen per watt efficiency. So as a result, you don't see any more imported or manufactured in the U.S. If you're in an establishment and they have incandescent bulbs they can purchase, well, what would happen is those are actually older bulbs. You could purchase those, but your energy efficiency wouldn't be that good. Furthermore, certain states like California having some regulations that came into effect, which not only are requiring high efficacy and performance, but they're actually requiring dimmers to be working with these lamps. And again, that's part of our whole outlay today. With that, I think I can turn it over to Bill in the room. The next slide.
Good. Thanks, Alfred. So we'll go a little bit just very quickly over some basic technical aspects of dimming. And as I mentioned, we really had a great run with the incandescent lamp. And one of the nice things is that it was easy to dim. When you look at the performance of a really basic dimmer using a couple of basic electronic components, you got tremendous range of dimming. You could dim it down to just barely on. You would have very smooth linear dimming. So right through its entire range, dimming was smooth. And this is what we all would like to see with our new lamp sources, and that's the challenge that we have coming to us. So the basic model that we use for incandescent dimmer is just a simple resistive circuit, and we controlled that with a device called or component called a triac that would just turn power on and off twice a cycle, and we'll talk about a little more about that in a couple of slides. When we look at a very, very basic model of what we're looking at for LED dimming, it's quite different. It's no longer a linear, it's a non-linear relationship with the dimming, and you look at the components. The photo at right is just showing you some of the components in a typical LED lamp, and the challenge is to control those in a manner so that it appears very similar to what we had with incandescent dimmer as far as the range, the smoothness, and all of those factors. There are lighting controls, as you know, I'm sure, that are now have been introduced specifically to work with these. So we'll talk about how those lamps work and how those controls work. Dr. Arun?
Okay, so let's talk a little bit about driver electronics. At the base of every LED lamp that you purchase, basically are electronics that enable you to drive LEDs. LEDs basically cannot be driven by an AC supply. You need to convert that to a DC, and that's what the electronic does. So while we never get to see the inside of an LED lamp, but for people like us who design these lamps, it's extremely important that we pay proper attention to the driver design to make sure that you, the customer, enjoys robust dimmability. So what really constitutes the key metrics that govern such performance? So you look at the pictures on your screen, and essentially you see two parts of the same circuit, the top and the bottom. And in the bottom, we've identified certain components for you. We don't need to get into the details of those, but a couple of key points here is that in any typical driver, depending upon who you purchase your lamp from, if it's a reputed manufacturer, typically there are certain things one has to consider for good dimming. One is flicker. How do you control flicker? there is a device on the driver called an electrolytic capacitor, which is very important in terms of optimization to minimize flicker. If that's not properly selected, one may observe more flicker than is desirable. Next is EMI. All of us are aware that the U.S. government requires the lamp to pass EMI standards. That's dictated by the regulation, essentially. However, what is not always known is that EMI and dimming essentially go hand in hand. Is often when you need to pass EMI, you might have to sacrifice some dimming performance. And proper optimization is easier said than done. So that's also a key consideration in design. Next, for good robust dimming, you need to have a high power factor. Power factors like 0.5 or 0.6 in that range aren't really conducive for good dimming. However, when you have high power factor, you have to handle high levels of peak current, which essentially are handled by a component called the power inductor. So proper selection and optimization of that component becomes an important factor in the design of the driver. Next, there is a thing, as you know, all of these dimmers are based upon the TRIAC semiconductor. So the TRIAC has a certain current called the holding current. And you need certain components in the driver that is called a bleeder circuit to satisfy the minimum needs for the TRIAC dimmer. If you don't design the bleeder properly, you're going to have issues with dimming. Finally, all of the points that we just mentioned, you have to keep in mind that you have to have certain real estate in the lamp, basically in the base, to handle this component. And that's, again, easier said than done. And also, of course, everything that you add has a cost consideration. So for a proper holistic approach to driver design to have good dimmability, you need to take all of these things into account. Next slide, please. A little bit more into comparison between the two lamp types, and Bill mentioned this at the beginning, I'll just touch upon certain key points, is an incandescent lamp, as all of you are aware, is basically a resistive load. The tungsten filament is basically a resistance, that's what it is. An LED lamp, on the other hand, is basically the inductive and capacitive elements in the lamp. So it's a whole different ballgame. And while intrinsically robust dimming is guaranteed with incandescent lamps, in an LED lamp, the robust dimming is far from guaranteed. And you have to have proper lamp design, and proper dimmer design, and proper testing of the lamp dimmer combination. Next, while the customer expects that when you use the dimmer and you move the switch from the high to the low, that you'll get a progressive change in brightness that we, in the jargon, call monotonic, that experience may not necessarily be guaranteed with an LED lamp and a dimmer combination, and you might have experiences during dimming of that lamp wherein you might find that the brightness is actually not changing as you move the dimmer, or you might have a plateau in the brightness. So that often happens with LED lamps. Finally, if you want to look at the physics of why everything is happening, like with flicker and everything, in the incandescent lamp, the very source of the light is basically the incandescence of the filament. And the high thermal inertia of the filament basically minimizes the flicker. It's a very large thermal inertia. On the other hand, the LED lamp is a semiconductor-based device which responds almost instantaneously to variations in current. And that's the fundamental difference leading to more flicker in the LED lamp. Next slide, please. Now, as Bill mentioned earlier about dimmers, dimmers fall into two broad classes, leading edge and trailing edge. Now, different people have different names for leading edge. Some people call them forward-phase dimming also. So what is forward-phase dimming or leading edge dimming? If you focus on the top chart, you will basically see what leading edge dimming is basically a cutting off the front edge of the wave. And the output of the dimmer is shown by the red curve on the right-hand side. Again, leading edge dimmers are the most extensively used dimmers in the US today. Most homes have leading edge dimmers. They're much cheaper than trailing edge dimmers, and they basically are TRIAC based, and they use a two-wire system. There is no third wire in a leading edge system. And basically they were designed decades ago for incandescent lamps primarily. And also a key thing to consider is that in leading edge dimmers, the dimmer power supply current flows through the lamp. Reverse phase dimming, also called trailing edge dimming, are use FETs. FETs essentially are field effect transistors, and they use a 3-wire system. They are intrinsically more expensive than forward phase dimming, and there's a much smaller installed base. And these, of course, are designed primarily for electronic low voltage loads. And unlike leading edge dimmers, for trailing edge, the dimmer power supply current flows through the third wire, the neutral wire. Okay, Bill?
Sure, and that's a great point, and that's a concern for ourselves as control manufacturers, and it's a challenge in many instances because a great deal of the installed base may not have access to that neutral wire. If you think of homes that were installed many years ago, they were designed exactly for that 2-wire configuration where the power supply was flowing through the lamps. But you look at the controls that we have now and the different options and features that they have built into them, they work best when used with a neutral wire. The nice thing is that all new construction, as we know, has to have a neutral wire in the switch box. The other challenge with LED lamps with a 2-wire is to get the reference of the zero cross. So if you recall that slide that we were just looking at that was showing the sine wave, is you really want to have a good reference to the zero cross so that you know when to trigger those on and off cycles. And that's a key part of the design of the controls that we make. It's much, much easier to get a good reference of that when you have the neutral and you have that separate power supply for the control. So those are some of the challenges that we face as manufacturers, and in some cases you will, well, in many cases, if you are having some issues where it's a 2-wire type application and you have an available neutral, you will usually get better performance if you're able to use a control that employs a neutral. So a couple of benefits. If you look at the incandescent, as we said, you didn't need the neutral. There's also a much lower cost when you did those kind of 2-wire dimmers. We are able to provide dimmers that are 2-wire dimmers that will work with LEDs and CFLs. You look at an ELV, and that's that trailing edge type dimmer, they will often perform much, much better with LEDs and CFLs. We show some of the trade-offs thing. One thing to note is that it's very easy, and we as consumers, it's real easy for us to just walk into any retail outlet and buy LED lamps and install them on in applications where there's, you know, a dimmer existing, an older dimmer that may be carrying just an incandescent only rating. And it may work perfectly fine. It may not. And that's some of the challenges because it's not designed to work with them. The listing is another consideration. We'll talk about that in a little bit as well. There is a listing that is rated to make sure that it is safe to use with those types of loads, because there are differences, and the specific difference that gets addressed in the safety ratings is the inrush current. So that's one of the main differences in the safety aspect of not using a control that's rated for the lamps that you're using. Okay, so LED CFLs, usually there is a little cost increase over those. It is the components, the controls, the design for those. And then the ELV, as we mentioned, uses a different type of technology, and that's usually, again, another, there's a cost to those components. Some of them can be listed for LEDs, and the listing is a safety listing. It's not specifically a performance-oriented listing. So what does that mean? We'll talk about this as well, is that you can control those loads, but it doesn't say anything about how well it does. It doesn't say how well it handles different LEDs, how well it does the range, how well it minimizes flickers. It's really a safety listing. When you buy a dimmer that says LED rated, it's not a performance rating on those. Okay, so that's the background portion of our presentation. So I think we're probably, a lot of us are familiar with some of the things that we talked about. So what we want to do now is talk about some of our challenges. And again, I encourage you, you have a chat box, and I know that lots of questions are already coming in, but we'd love to hear about some of your specific challenges and questions. If we can't answer them today, because we are trying to leave sufficient time for a Q&A session, we will try and get back to everyone who asks a question and make sure that they get an answer, whether we can get to it or maybe don't know the answer today, but we will try and get that. So let's talk about some of those basic challenges. And this is what you'll commonly see. And, it's funny because you have both lamp manufacturer and a control manufacturer participating in the webinar, and I'm sure just like Leviton, when we hear issues in the field, they're asking, hey, what control should I be using? And then other times we'll hear the question the other way is, what lamp should I be using with this control? Because the issues that are listed there. Sometimes you don't see a full difference. Sometimes you may not turn on at the lowest level, or you may have flickering. Noise can be an issue. So I think we've all seen these types of things. And the bottom line is there are usually things that you can do, depending on the control of the lamp you're using, that will optimize the performance and make you satisfied and your customer satisfied. Dr. Arun?
Yes, so we can go to the next slide, I think. We got good lead off into the next one. So we can go to the next one, I think, Bill, yes. Yeah. Okay. So right now, the technical challenges in achieving robust dimming. Let's talk a little bit about this, good follow-up from what Bill just said. As we all know, LEDs are really dynamic in nature. In the past 5 to 6 years, there has been a dramatic increase in LPW of the lamps. LPW basically refers to lumens per watt. As LEDs get more and more efficient, the lamps are getting more efficient. So what does that basically mean, and why is that relevant to dimming? Why are we talking about it here? That's because as LEDs get more efficient and as lamps get more efficient, what happens is the wattage of the lamp goes down. So you're essentially creating the same amount of lumens with a lower wattage of lamp. For example, A60 lamps have essentially decreased in wattage from about, in fact, 11 to 12 watts in the past several years down to the low 6s nowadays. And why is that important? As the wattage goes down, the current required to drive the LED strings goes down. And essentially all of the triacs that we just spoke about for leading edge dimmers have a holding current, and you need to satisfy that. So as the current goes down, the current requirement, it becomes more and more challenging to provide these minimum holding currents for the triacs and makes dimming more challenging. So basically, as LEDs have progressed towards higher LPW, the dimming essentially gets more challenging, and that's the physics of it. Next is market trends. As over the past few years, the trend essentially has been to minimize the amount of heat sink that you, the customer, sees in a lamp that you buy. And you may have seen this, the amount of heat sink that the lamp has, or if you want to reverse it and look at it from the point of view of how much plastic there is in the lamp in terms of the cover, essentially you're going from a snow cone type of a lamp that you bought 5 years ago, essentially to a lamp that replicates more and more what an incandescent lamp looks like. So what am I saying here is that as the market goes more and more towards the incandescent type of aesthetics for the LED lamp, essentially the amount of space that is available for the driver electronics progressively goes down. And ultimately, you have to fit the entire driver electronics in the small base at the bottom of the lamp. That poses a major challenge if you recall back to what I just said a few slides ago, that you have to put in certain minimum components for EMI control, output capacitors, bleeders. So it really gets challenging to fit everything into a small real estate. Finally, the third point is, as the market also wants different aesthetics, there's also a constant downward pressure, both on the lamp and on the dimmer manufacturer. So that also poses its own separate constraints. Fourthly, there is an evolutionary change. Just like lamps are going through changes, dimmers are going through changes too, the evolutionary process. And it's almost impossible to test every possible dimmer and lamp in the market. And also dimmer manufacturers are going from analog control to digital control. They're introducing new features like RF remote control. And of course, the big giant, of course, the fact that there is essentially a lack of industry standards on LED lamp dimming performance. We'll talk a little bit more about it in the coming slides, but that inherently is the case.
Great, thanks. Sure, so let's talk about some of that testing, because if everything was perfect and we worked as well as you know, we always had with incandescent, we wouldn't need all of this, right? Because it would just plug and play. But the bottom line is that Leviton and Ledvance do all kinds of compatibility testing with controls and LED lamps. And that's true not just of us, but probably every manufacturer in the business. As we just heard, it's becoming a real challenge, because you just look at the variety of what's available, both on the control side, and now some of these smart controls, which there's a whole bunch of new controls constantly being offered, as well as the lamps and the new form factors. So it becomes increasingly a challenge, and I think the bottom line will be when we start getting to true industry standards of compatibility. I think that'll make it easier for everybody, and there are, of course, challenges to get that point. But these are just some typical tests that we would do in our labs, and if you compare that to what we did, I'd say, several years ago when we first got into compatibility testing, it was probably having an applications technician sit there with a dimmer and you know, look at a light and say, yeah, that's flickering, or that's not flickering, and how far it dimmed and things like that. It's become more and more technical, and I think that's something that you're going to see throughout the industry. So what we'll typically do is, this is a battery of tests that we'll do, is we'll just go ahead, do the turn on, measure the light output, note how quickly it turns on in response to the controls, how quickly it turns off. We look at what kind of current goes in when it's first turned on. Again, I mentioned the safety standards of UL and other testing laboratories. That's one of the real concerns when you get the listing on there, is the inrush current. And then we have different equipment, or we have equipment that measure specific performance issues. For example, flicker. Now we're putting these on to equipment that will measure, probably better than the human eye can see, what kind of flicker is coming off of any lamp during any point in its dimming range. So that's both visible and other flicker that may not be evident but could impact you. So we do measure that, as well as audible noise. One other thing that I'd like to point out, and you see that picture in the bottom right, and I think all of the manufacturers list or test compatibility with different numbers of lamps, because adding different numbers of lamps can also impact your performance. So if we're going to give a compatibility rating and make sure it's performing well, we're going to do it with a full range of lamps that you might typically use. So in that rack right there, you see eight lamps being tested at a time, so it'll test from 1 through 8 lamps. So Leviton has equipment, and there is industry equipment that you could buy, like I said, specifically to measure things like flicker. But as we mentioned before, there's just a tremendous range of lamps becoming available. The introduction into these is pretty steady. You look at the offering today versus a year ago versus what you'll see 6 months ago, and you will see lots and lots of new products. exciting products, but there are differences in performance. So the industry, as we mentioned, is marching, sometimes too slowly, but it is moving towards having some more consistent testing standards and compatibility. Now, did you want to jump in on this as well?
I do, and everything you're saying is true, but the key point here is the life cycle of the LED lamps is rapid. And as rapid as it is, meaning it could be January and we have a lamp that we're designing and ready by May, even June, if not sooner, and that incorporates whatever it is for dimming, and then another set is coming out, so that's happening. But also for folks to understand that, there were two different manufacturers talking today, and the testing that we do is far more robust than some no-name types that are out there, and that has an impact. And so buying what's reliable, you get what you pay for in this case, and we really want to emphasize that there is a lot of compatibility testing, both ourselves and at Leviton, looking at how is that experience going to happen, what will be out in the field when people are using these lamps. In fact, we even have on our website a listing of our lamps that whether they're dimmable, including with Leviton, to help folks when they're making their selections. Back to you.
Great. Good. So let's talk, Dr. Arun, let's talk about some of those specific industry standards and efforts that we've got going on.
Very good. So let's focus first on flicker, and that seems to be a major source of annoyance for many customers. So let's see what has happened over the years. Let's first start with our federal government. Energy Star. Basically, Energy Star came up with two metrics, if you will. One called the flicker percent and one called flicker index. If I could draw your attention to the graph at the very end of your chart, where you have the graph with the blue and the green up there, basically flicker percent essentially is a mathematical metric that takes the maximum of the waveform minus the minimum and divides it by the max plus the minimum, and you get a flicker percent. However, while that's a very easy thing to measure and report, unfortunately, its physical significance is rather limited. It doesn't take into account the wave shape, frequency, nothing. The flicker index, again, derived from the same waveform, if you again look at the same graph at the bottom, it's basically the area above the mean, the areas in the blue, divided by the total of the areas, the blue and the green, and that's the flicker index. So this has been around for some time. People do report it. In the absence of anything more sophisticated, a lot of people still stick to it. But as I said, there's some fundamental deficiencies in both of those matrices. Then you have California Title 24. The Joint Appendix 8 talks about a certain guideline of flicker percent, preferably should be less than 30 for frequencies less than 200 hertz. Again, single metric has its own issues. Then other universities and consortium have, over the recent years, come up with their own guidelines for flicker. For example, the University of Rensselaer Polytechnic, RPI, the Lighting Research Center, has a guideline for perceptible flicker, meaning for frequencies less than about 80 to 100 hertz, in that range, less than 100 hertz. And then the IEC, of course, has its own short-term flicker indicator called the PSC guideline. And then Philips came up with something that they call SVM, short for stroboscopic visibility measure, and that typically applies to stroboscopic effects, which are for frequencies more than 80 hertz. I'd like to stop here for a while and say, there are two types of flicker in general, static applications and so-called stroboscopic applications. And not everything in life is static. For people who are used to doing task jobs, yes, for them static flicker is important. That's a frequency less than 80 hertz. But for people working with moving things like machinery and other things on the floor, the stroboscopic effect is equally important. Then IEEE in 2015 came up with a guideline 1789. All of these metrics have some sort of deficiency or the other, and we will not delve into the nitty-gritty of the details there. But I do want to bring something up, is they're all single metric standards or guidelines, if you will. So NEMA is trying to address that with a new white paper, which is the LSD-75. It's supposed to be out any day now. Basically, what they're proposing there is a dual metric standard, or a guideline, if you will, where they're talking about guidelines for frequencies less than 80 hertz and guidelines for frequencies more than 80 hertz. So basically covering both the PSC and the SVM. And why is that superior to the others? That's because it covers both the aspects of flicker, both for people working in task-oriented applications and for people working with, moving things up there. And basically, without getting into the mathematics of LSD-75, basically what it does is it takes the lighting, the waveform that is essentially what light comes out of the lamp, and essentially converts that into a frequency domain using fast Fourier transforms, removes certain unwanted frequencies, weights certain frequencies in a certain way, normalizes them and sums them up, and essentially that's what it does, is what the mathematics behind it is. And what we hope is once NEMA LSD-75 officially comes out, that standard bodies like IEC and others essentially will take it and adopt it and make it into a regulation. And in fact, there are currently measurement devices out there made by a couple of manufacturers which can measure both the PST and the SVM aspects of LSD-75 to help the customer ascertain the effects of flicker on the lamp that they're getting, lamp-dimmer combination. Next slide, please. Apart from what we just talked about in terms of flicker, NEMA also has been working on other aspects of dimming. However, so far, the emphasis really has been on the basic compatibility. By that I mean that, okay, when you buy a certain lamp and a certain dimmer, if they are both NEMA SSL 7A compliant, then when you put the two of them together, the one will not destroy the other. So essentially, the very basics of compatibility, NEMA SSL 7A doesn't essentially outline any standards for dimming performance. That will hopefully be addressed in SSL 7B, which is still in the works, and we're still some way away from it. But basically what NEMA SSL 7A does is it essentially helps the people, the dimmer manufacturer and the lighting lamp manufacturer, to prevent having to test a plethora of lamp dimmer combinations. So basically you have a standard waveform generator that simulates, if you will, the dimmer, and the dimmer manufacturer essentially has a standard synthetic load that simulates a lamp. So basically it's a very detailed standard, but again, I wish to emphasize that the SSL 7A is a basic compatibility standard. It is not, by any means, a performance standard. Next.
Great. Thanks so much. That's great. Hey, I promised at the beginning that we're going to have time for Q&A, so I'm going to go through very quickly a couple of basic troubleshooting things, and maybe we could call these helpful hints or things to look at. So we'll start at the most basic of all. If you missed this one, you're really in trouble, right? Dimming is not doing it, and number one, make sure that you have dimmable lamps, because there are lamps that are both dimmable and non-dimmable LEDs. And I don't know, Alfred, did you want to make a comment on that?
That says it all, and absolutely look on two parts. Look on the package and look at the lamp. On the edge of the lamp, it'll say DIM. That's actually regulated by Energy Star, and we as manufacturers will put that if it's dimmable. That will solve the majority of the questions right there. Just make sure. And then back to you on make sure the dimmer is controlled for an LED lamp as well. If the dimmer is in the wall and Nixon was president, it's probably old. Yep.
Oh, that's the old make sure it's plugged in type of first law of troubleshooting, right? So a couple of things. What do we see? We hear the LED is still illuminated, where you may have ghosting, or what we call bleed through, or something like that. We talked about the 2-wire versus 3-wire options. If you have a 3-wire option, you have a neutral. That's always better to use. But one thing, and you could look at the controls today, and you could start with basic controls, and then you could have all options. So if you have controls that have locator lights, try and make sure that if you're going to use it with LED lamps that it is switchable. So in the picture on the bottom, you see that there's a switch to shut off that locator light. So that could eliminate that ghosting or bleed through. Flickering at the low end. Many controls these days, and there's a full range of controls from your very, very basic rotary to, electronic ones that are connected with different technologies. But if you look at your better controls, you're going to have programming modes that you could adjust the low end, so that if you do have a lamp, you could say, you know what, I just want the dimmer to start at this level and then go to max. So I eliminate that very low end where I may have some issues. So many controls, specifically those that are designed for use with LEDs, will have that option. Just general poor dimming range or performance, again, compatibility is the key. And we'll list, and we look at the other manufacturers and the lamp manufacturers, they will list dimming range. And sometimes it's hard to predict these, and that's why we do the actual testing, is that we will say, this is the dimming range that you can expect between this control and these lamps. One of the other things with LEDs, and we mentioned it before, and we didn't talk too much about, we talked about the options and the new product development cycles, but, they're all different colors and shapes and things, so many different things available that if you start kind of mixing and matching, it could look pretty funny sometimes. So it is important, if you want that consistent lighting and dimming levels, that you're going to use a similar lamp right throughout the application when you're using multiple lamps. Exceeding the maximum number of lamps, if you look at the bottom photos that I put in there, you have an incandescent lamp and one that's rated for LEDs and CFLs as well, and there'll be a rating for both. So in this case, the one on the left is a 600-watt incandescent. It's a 150-watt CFL LED. The one in the middle is 600-watt incandescent, but it's 300 watts LED CFL. The one on the right is a 1,000-watt incandescent. It's 450 watts. So there's not a direct relationship. Again, that listing is a safety listing that says this control can handle this much wattage of LED lamps, and it's really based on the inrush current and what that control can handle. So that's something else that you should consider. Not all the ratings are equal. A couple of other factors that I'd like to throw out there, and then we'll turn it over to questions and conclusion. Sometimes we see other controls that can be very, very noisy, certain fan speed controls and fan motors and things like that. If those are used in conjunction or adjacent on the same circuit, you could look at some of those sometimes. Some fan controls are much noisier than others. Some fans are much noisier than others. For those of you that are using more commercial applications, power quality can be an issue, and it could impact performance of both the controls and the lamps. Residentially, it's probably not as much of an issue, but in a commercial facility like I'm in right now, the performance, if we do compatibility testing on house power versus clean power, we could have differences during the year if the chiller's on or something like that. So if you have like a large MDU or a commercial facility, keep in mind that some other loads can actually impact how things perform, and it's important to have really good power quality in those types of facilities. So I'm going to wrap it up, and I don't know, I'll go through these basic conclusions, and Alfred, you could jump in as well. As we said, use the LED rated controls if you're dimming LEDs. If you have questions, you know what, we as manufacturers, we want to optimize the performance. We want you to optimize your performance so that you're going to look best. That consumers are all happy in the end. So if you have a question, we are easy to find and easy to contact and more than happy to help with you. Look at the compatibility charts. If there's something that you are seeing and using commonly that's not on the compatibility chart, you know what? You can call us up and I will get it in queue. And I think, Alfred, you had said, you know, there are relationships of performance and price sometimes, and sometimes you do get what you pay for here, right?
You absolutely do, and I can't emphasize the point you made a moment ago about mixing lamps and brands, because consistency in color with LED is really important. That after you put all that effort in, whether it's a room or in a corporate facility, you want to have that same appearance. And as far as the website that we have and our compatibility list, it's very important you check that out and know that it's a compatible and it's a tested lamp with that tested dimmer. Everything we covered today should make it easy, and feel free to contact us as well, and we'll help you with that performance and that job.
Awesome. Thanks so much. Hey, Tim, I think that's our presentation. Did we get any questions come in?
Yeah, we got a bunch of questions, actually. So hopefully I'm going to fire them at you guys, and hopefully we can get to as many as possible before the 3 o'clock hour comes along. So first question, some PEs are designing LED lighting circuits with multiple types in same circuit and dimmers, such as LED lamps, LED drivers, etc. This makes it very hard to find a dimmer that will work satisfactory. Do you guys have any recommendations there?
Could you just say the first part of that?
Sure.
Oh,
some PEs.
Okay,
yeah.
Good. Okay. Yeah, and that's a it's an interesting question, and I don't know, Dr. Ruud, do you have a comment on that?
Yeah, essentially, like I mentioned, is every dimmer is sort of unique in terms of the capacitors and inductance, and as other lamps. So now, essentially, the magnitude of the problem is magnified tenfold when you have different lamp types, you know, and different manufacturers. So it really, from a physics standpoint, it's really difficult to find one dimmer that will work in a circuit where you have different lamp types and different manufacturers. That, I think, will be very, very difficult. The only way of doing this with the Edisonian approach essentially is once you decide the different lamp types and makes you want in the circuit, then preferably, you know, get one or two dimmers from the big dimmer manufacturers and test and see which one works. That would be my recommendation.
Yeah, I would second that, and I would also, you know, volunteer the manufacturers of both the lamps and the controls if we want to, if you need someone to consult with and talk to some of the PEs that are doing the specifying to say, okay, let's understand what the goals are and make sure that it's going to work as specified.
Okay, great. So the second question, it's regarding lumen output and color temperature. Are the measurements using the same standards as incandescent?
The measurements used, this is Alfred, the same standards incandescent. Well, when we measure the lumens in the same sphere and using the same material and items and machinery and all of that stuff in the lab, just like we would measure an incandescent, that's correct. And as far as the color temperature, the incandescents were predominantly in the 2700 to 3000 K, and with LEDs, we've actually followed suit with not only that color, but 3500, 4100, and 5000 K into the daylight, much like you had in compact fluorescent. So in essence, yes.
Okay, great. Next question. In three-phase power distribution, the neutrals, should they get swapped? Say an A phase neutral gets crossed over with a C phase neutral that creates havoc. Due to each phase being 120 degrees out of phase with each other, how can we address this?
Well, this is Bill. I'm going to consult with my engineering group, and we could issue an answer to that. for you.
Okay, so should we move on to the next question then?
Yeah, let's move, unless, I don't know, Dr. Arun or Alfred, if you have anything on that.
I think we're going to agree with you on that one. That's something with the technical folks in the background will have to help us with.
All right. Next question. Some Ps aren't even aware of the WOV neutral sharing. Does it matter on a single-phase distribution system if the neutral is swapped?
Sounds like we're following up on that theme. So we'll try and get a full answer on that line of questioning, Tim, and hopefully we could issue it to either directly to the respondents or as part of whatever we post online with regards to the webinar.
Yeah, absolutely. I can note that we had some questions regarding this topic, and we can have an answer in writing.
Mm-hmm.
Okay. So the next question is, we recently completed a restaurant that was total LED. This had numerous Halo, SLD, 6 and 4 LED lights mixed with fixtures and LED lamps. The flickering was so intermittent and it would work at times and then flicker. They installed reverse phase dimmers and incandescent, and then the question kind of runs out. But do you guys understand the question there?
Well, clearly, and this is what we'd love to get more detail and more information on is specific, and this is good. It's got specific lamps, and we'd like to know what controls. But I guess the second part of it was, I think, important to me is that, yes, sometimes a reverse phase will work much better for those applications. So I'm not sure if it worked in this case or it didn't work and then they ended up going to some incandescent. But yes, a reverse phase is usually a very, very good solid option.
Okay. The next question, do certain dimmers produce less harmonic distortion? I've noticed interference with high-end electronics and PV systems not functioning properly when dimmers are being used.
Absolutely, and as Alfred mentioned before, when you get to what we'll call a quality dimmer, it's going to have very, very good filtering, and some of what you could get, one of the things that you would sacrifice on the very low end and low cost is some filtering.
All right. Can you provide the NEC section requiring a neutral wire in each switch box for new construction?
Right now, normally I'm pretty good with those numbers, but that specific section, we will get it, and I'll shoot that out to you. Also, I'll shoot out the first year that it appeared, but I think at this point it's been around long enough so that the entire country is under that requirement.
Okay. If you have only 2 wires at the switch, what are your options if you want dimmable LED? What about non-dimmable LED?
Well, yeah, you could always just put a switch, but there are 2-wire options, and there are even some nice electronic dimmers that can run in a 2-wire application. As we said before, you do get concerned, and it becomes more challenging even as this efficacy increases and you get more lumens per watt, therefore lower wattage and things like that. So it is a challenge for the control manufacturers, but we're continuing to address that, and there are products that will work in a 2-wire application and work very well.
All right. What is the percent for forward and reverse dimming in the market?
I want to take a room.
Yeah, Bill, what would you say? I think it's about 95% or so forward phase, leading edge.
I would say 95 plus. I'd say yes.
Yeah.
Yes, you look at the volume, the real high volume. It's 95+%.
Yeah.
Okay. We haven't had any problems with 0 to 10 volt LED dimming. It's the forward and reverse dimming that seems to have 0 standards. We recently found a Legrand dimmer with both forward and reverse selection on the same dimmer. It seemed to work great.
And I think that's what you will be seeing from the control manufacturers as we go. There's going to be more and more flexibility and adaptability. As we said, this is dynamic. It's dynamic on the lamp side. It's been very dynamic on the control manufacturer side. So I think that's why we're having this webinar, right? We were trying to get everyone up to date and, you know, just stay posted. You're going to see new products, new controls, new lamps on a regular basis.
All right. Next one. We have had to install some incandescent lamps in line with LED dimmers to stop flickering. Is that something you guys have seen before?
We have seen that, and I don't know, Alfred, if you've seen that as well, is sometimes you put that resistive load there that it kind of helps the situation. Now, it may not always be the most aesthetically pleasing thing, but sometimes, you know, if they could hide an incandescent one, I've seen that work as a fix in certain applications.
We have seen that. We understand those reports. You lose the energy efficiency, however, Bill, and that's a concern. And it gets folks to get in touch with us, and let's see why and what's going on that's driving that. Is there interference, something in the power line that's causing that flickering in the first place? Is it incompatibility? We've actually seen it once or twice with lamps that aren't dimmable, and also on a dimmer that is not marked for LED lamps. So it's a lot of the troubleshooting points we went over that are resolved this way, but it's not a positive energy plus. And again, if color temperature plays a role here, especially if it doesn't match in that incandescent.
Okay, I'm going to just do a few more. Let's see. So when dimming LED, has anyone had trouble on the low end with flickering?
Yeah, that's probably the most common occurrence, is that the flickering essentially happens at the low end. So that's very common.
Yeah, and that's what I had mentioned before, Tim, is that a lot of the controls, and I know I'm not a big instruction reader all the time, but check it out. You may have an adjustment on there so that you can program in your minimum turn on so that you get the full range and it stops the dimming where you might be seeing the flicker if you have that type of application.
Correct.
Okay. We use the Leviton power extenders with next-lit dimmers to help isolate the load in rush. However, we are experiencing flicker when the LEDs are tried to dim very low. Any suggestions?
Yeah, that's a great question that I'm going to bring over to our commercial folks in that technical group. Okay.
Okay. Just real quick, I'm scrolling through the questions and answers. One of our attendees noted on the code question earlier, it's NEC 404.2C for the article that requires neutral at switch boxes. I just wanted to throw that in there. And it looks like another attendee confirmed that. So, all right, I'm going to do one more question here before we get wrap this up, since we are after 3 o'clock. See, next one was, the situation is the switch does not require dimming. Want it part of home automation control, let's say an OmniPro 2. It's an old house, so 2 wires are at the switch. The current switch is not controlled. What to replace with the switch that can be controlled by OmniPro? What are the options?
Okay, I will get an answer for that one as well.
Okay.
I think we've got that question, yeah. Okay, we've got that one noted down. I'll get the answer on that one.
Okay, perfect. Okay, guys, well, since it is after 3 o'clock, and I know many of you have businesses to run and your times are valuable, we want to respect that and go ahead and close up. Hopefully we can get answers to the rest of those questions out to you, and we'll be notifying you in the next day or so when the recording is up, so you can come back and view anything you missed or share it with some colleagues. On behalf of Electrical Contractor, Leviton, and Sylvania Lighting by Ledvance, I want to thank you guys for attending. I want to thank Bill Grande, Alfred Laspina, and Dr. Arun Dutta for an excellent presentation. And be on the lookout for the recording. And I'm going to go ahead and end the event now. And we hope to see you at a future webinar. Thanks, everyone.
Thanks, Tim.
Thank you.
Thank you.
Thank you all very much.
Bye-bye.